Open up to the Target Lab Heat of Solution. Today we will be practicing calculating enthalpies of solutions in the Target Lab. Once your lab is open, you'll be given a list of reactions, not chemical, but physical. The following salts have been written down for their dissolution processes, meaning they start as a solid salt and then they get dissolved in water. When that process happens, you'll note that some of the salts will absorb energy. For example, ammonium chloride will take in energy, making the surrounding water colder. So that would be an endothermic process. Whereas some salts, like calcium chloride, will exothermically release energy, making the surrounding water temperature hotter. All of these tabulated standard enthalpies are in units of kilojoule per mole of the salt. The salts that I'm going to have you guys experimenting with today on your own is going to be potassium chloride, that'll be found in the back middle table where all the mass balances are, and calcium chloride. Note one is an endothermic dissolution enthalpy value and one's an exothermic. First, let's do the pre-lab together, then I'll explain the lab task and you guys can execute and clean up. Okay, in the pre-lab, you have been charged with finding the means of changing the temperature of a 250 gram solution where the water starts out at 22.3 and we're trying to get the water to heat up by 12.5 degrees Celsius. Number one, calculate how much energy the water has to absorb if we've got a 250 gram solution. So in number one, we're going to go ahead and do Q equals M of the solution times C times delta T of the water. That's going to include 250.0 grams times the specific heat of water times 12.5 degrees Celsius. The energy comes out to 13,075 joules, or 13.075 kilojoules. When we round to sig figs, we'll keep 13.1 kilojoules of energy. All right, that's the amount of energy water will need to absorb, 13.1 kilojoules, when it goes up 12.5 degrees Celsius. All right, now it says switch the sign to know the amount of energy that the salt is releasing into the water. Well, that's simple enough. We'll make it negative 13.1 kilojoules. Convert this to kilojoules. Oh, okay, we already did that. So go ahead and just copy that down. Does the water absorb the energy or release? Of course it absorbs it, since the delta T is positive. Is the dissolution of the salt exothermic or endo? Well, it's got to be releasing energy to the water, so it's exothermic. Use the solvation equation to calculate the mass of potassium acetate needed. Okay, so it says let's use this salt, which you'll notice does have a negative enthalpy of negative 15.3 kilojoules per mole of salt. So we can use that in order to figure out how to change the water 12.5 degrees. But the question is, how many grams of salt do we need and how much water do we need? And then, of course, we're going to need a calorimeter to do the experiment, right? All right, so we're going to do potassium acetate. We're going to start with the energy that is associated in our problem. So we had negative 13.1 kilojoules of energy. And now we're going to use a conversion that takes energy and relates it to moles for potassium acetate. That's the standard enthalpy. That's negative 15.3 kilojoules per 1 mole of potassium acetate. Finally, convert 1 mole of potassium acetate and relate that to, the number of grams in a mole. And so I'm going to actually cheat here real quick and look up KC2H3O2 just to make things go a little bit more quickly. And we'll note that potassium acetate is 91.85 grams per mole. Rather, 98.15. 98.15. You guys would want to confirm that by adding up all of your molar masses. Okay, let's do the multiplication and division. And we'll get a value of 84.0 grams of potassium acetate. All right, now that begs the question, if we know how many grams to measure out, how much water do we have to put it in? And then it's going to dissolve and make our solution, give off the energy, and we're done. But how much water do we need? Well, we need a 250 gram solution. So that's when the salt or solute is dissolved in the water. So 250 minus 84 gives us 166 grams of H2O. This much water plus this much salt will give us a total solution of 250 grams. Okay, when the salt is dissolved, we should get a temperature change of somewhere close to 12.5 degrees Celsius, assuming that we executed our lab technique appropriately and we've got a decent calorimeter to use. Okay, with that being said, here's what's going to happen. You guys today are going to practice with those two salts that I labeled above. You'll be able to find potassium and calcium chloride and experiment with them. I want you to do 2 trials. So each trial, you're going to have to build a coffee cup calorimeter similar to the other day when we did the specific heat capacity of the metal, where you will dissolve the salt on the inside of the water. Make sure you get the water temperature first, and then you measure out the mass of your salt, and then you toss the salt into the water, give it a good mix, and record the overall temperature change. You guys are going to attempt to hit a target temperature change of, I'd like you to do 2. One where the water is going to heat up, positive 6 degrees Celsius, and one where the water is going to cool down as it loses energy to the salt in an endothermic reaction, negative 5 degrees Celsius. So please attempt these 2 delta T's using the 2 different salts available to you. You will need to do your calorimeter with a 100 gram solution total. So that's the salt plus the water. And then you can use your equation and the stoichiometry that we just took a look at from number 6 to help you figure out how many grams of salt and how much water to combine on the inside of your coffee cup calorimeter. Then you'll want to grab yourself a thermometer, and you guys will be able to run the lab. When everything is done, please clean up the coffee cup calorimeters as well as the salt. Make sure that stays in the back middle of the room, and the thermometers can go in the little thermometer stand. There are weigh boats in the back that you guys can use to transfer from the weigh boat into the coffee cup calorimeter when you're trying to toss the salt in. And you can use the distilled water from the wash bottles. The Gatorade is full. Feel free to fill up each wash bottle and grab a graduated cylinder to measure out your water. And good luck. Calculate your percent error at the end for some extra fun and knowledge. All right. Best of luck. Bye-bye.